Students, I welcome you all to yet another session of my series dedicated to help students of classes 11 and 12 having computer science as one of their subjects. This session is dedicated to stacks in Python as per class 12 syllabus of CBSE. My agenda is to help and support students juggling with various subjects like they have PCM along or they might be having other main subjects along. Okay, so I'm helping them in getting time, and in this juggle they are not getting time to study CS, so I'm just providing them a quick sneak peek and on how to solve questions, okay, from this topic. So my intent is to provide them topic wise quick revision and question practice as per board exam. So now, without taking much of your time, I start with today's session on stacks in Python, right? Okay, yeah. So, first of all, this term stack. What do you literally understand? Like, what does this term literally mean? Stack is arranging, okay, any item on top of each other, right? I'm stacking this item, okay? I'm placing this item. I'm stacking this item on this. I'm stacking the third item on this. I'm stacking the fourth item and fifth item and onwards, right? So this is just a way of arranging, okay, items. I mean, just a way. And when you arrange something in a particular manner, then there are certain, ways that you need to follow to use them, okay, to add something to the stack, to remove something from the stack, or just going through the stack. You cannot just do it randomly, or rather you shouldn't be doing it randomly, okay. Like for example, plates. My plates could be arranged in this fashion. Okay, there's no harm in this. They are just spread across. And another way of arranging my plates would be what? This, on this, then on this, on this. This is how I'm arranging my plates stacked upon one another. Now, if you have all your plates arranged like this, which plate are you going to take off the first? The bottommost or the topmost? For obvious reasons, the topmost, right? You're going to take off the topmost. You're not going to pull it off from here. Everything's going to fall off, right? Likewise, if I have to add a new plate, what would I do? Would I pick all the plates and place it beneath? No, I'll just place it on the top. So you're seeing, if anything is arranged in a stack way, then insertion, deletion, both would happen from the top only, correct? Both are happening from the top. So basically it's what? It's a structure in which things are being arranged. Fine. Likewise, I take an example of a queue here. I'm not, as of now, I'm not just moving, okay, into your programming concepts or anything. I'm into very real life ideas, very real life concepts of a stack and a queue. You all know what a queue is. Okay, there are many, okay, say this person 1, this person 2, this person 3, this person 4. They are all just, standing like this. And I ask them, okay, you're not supposed to stand like this. There's this window. Start standing here in a line, or rather make a queue. So it's going to be like P1 is standing here, P2 is standing here, P3 is standing here, P4 is standing here. Now you just see what type of arrangement and structure is it. It's a queue type of a structure, queue type of an arrangement, right? Now the same thing if I see in a queue, what happens? Again, how is it going to function? If there's someone who's to be added to this queue, say P5 is ready to be added. So P5 is going to come where? Here or here? P5 is going to come here. And if someone's to be removed, who's going to be removed? P1 is going to be removed. So now P2 is at the first position. So what's the difference between a stack arrangement and a queue arrangement? In a stack arrangement, insertion, deletion, all is happening from the top. Okay. And in case of my queue, what is happening? Insertions happening at the end and removal or deletions happening at the beginning, I would say, not top here, at the beginning, right? So you see the difference in, depending on how data is structured, okay, your access to the data, your traversal of the data, your data manipulation changes accordingly. Getting it? See, I'm again and again using this term structure. Okay, structure. What am I structuring? Say I'm structuring data. So now you must have understood, if I'm using this term data structure, what does it mean? It's the way in which I'm arranging my data. I'm structuring my data. Okay. And that's data structure. Okay. In a very simplest form that I could explain you all. And if I broadly classify data structure, now I'm moving on to programming language. Okay. And in any of the programming languages, broadly, I can classify my data structures into two types: linear, okay, and non-linear. I just took example of two types of structures here, stack and queue. Both of these come under linear data structure. Linear means something that is aligned linearly. Okay, one after one, that's linear, right? Non-linear data structures are what? I'll just take few examples. Tree, graphs, and even heap for that matter. These all come under non-linear. Non-linear means they are not aligned in a linear way. It could be like a tree. How is a tree arranged? A tree is arranged, okay, in this way. Okay, graph. How is a graph arranged? A graph can be arranged like, like this. So these are definitely not linear. But a stack, like you saw, arranged like this is linear. A queue, like you saw, arranged like this is linear. So broadly, we have two types of data structures: linear, non-linear, and classifications of linear are stack, queue, okay, broadly. And classifications for non-linear, the most common ones are tree, graphs, and heaps. Okay, now depending on how data is arranged, the way you're going to access the data would change. The way you're going to work upon your data, remove data, add data, everything changes. You access a data in a tree in a different manner, in a graph in a different manner, in a stack in a different manner, in a queue in a different manner. As of now, our scope is stack. So further in this session, I would be explaining how a stack works, right? How a stack can be made, how a stack can be accessed, how can data be added to stack, how data can be removed from a stack. So focus is going to be on data as per our syllabus. Yeah. Okay. So now in particular, I take up stacks in Python. Okay, so broadly, stack is what? Stack is arrangement in a linear arrangement of data information in linear format, right? In a linear way. So now I need to understand, how do I implement, okay? How do I implement stack in Python? How am I going to do it? So I need to look out for a Python object or a Python data type, first of all, which is linear, okay, as far as its characteristic goes. And second, it shouldn't be read-only. It should be something to which you can add data information or remove data information. And the most suitable that I see is a list. Okay, so I use a list, okay, from all the available data types in Python to implement stacks in Python. Getting it? So you're understanding why stack. First of all, it's linear in nature. Second, it is mutable. Okay, so until unless I have this mutability in a particular type, there would be no point, using it to implement a stack. A stack is a data structure wherein I should be allowed to add elements, I should be allowed to remove elements, and stuff like that. Yeah. You know what? So what does it suggest? It suggests that if I have a list, right? See, I'll just show you. This is my list. Okay, this is my list. This is my index 0, 1, 2, 3, 4 and onwards. Now the same thing, what I just said is that the stack in Python is going to be implemented using this list. So what I do is I just lift it up, okay, and it becomes like this. Yeah, 0, 1, 2, 3, 4. See, what I'm trying to show you here is that stack is nothing just but a normal list that you're working on Python, not a big deal. Now you just see, I'm saying insertion, deletion both can happen at the beginning, at the end. I'm so sorry, I just said beginning, at the end only. I'm so sorry, yeah, at the end. So, top, here at the top. Fine, here at the top, this is index. I'm so sorry, I said beginning, I think, yeah. So, So now just see, my list just tilted upwards is a stack now. And insertion, deletion, both can happen only at the end. Okay? At the end only. You can insert at the end and you can delete from the end. So what does it mean here when I talk or say the same thing in terms of a stack? Means insertion, okay, and deletion. Both can happen only at the top or at the end. What does it mean? It means the data information that was last in will be first out, right? Yeah, or I can even say first in will be last out, correct? So this is called abbreviated as LIFO and this is abbreviated as FILO. So if someone asks now, what is a stack? So first of all, your first point is going to be stack is a linear data structure. Second, okay, it is a LIFO oblique philotype of data structure. Okay, in Python, it is implemented using list. And for what reasons we have already understood. Okay, now next I move on to, like I said, definitely I'm arranging my data. So there's a reason of arranging data because I want to access and work upon the data in a particular fashion, right? I just don't want a random access to data. I want it to happen in a fixed way. See, there's one thing I want to add here. Anything that you're doing, programmatically, it's actually, mapping to real life. So stack, the idea of arranging data information in stack also has come from real life. Arranging our data in form of a queue structure also has come from real life. Okay, then having data arranged in a tree format, again hierarchical data has come from real life. So anything and everything that we do mostly is simulated as per the real life happenings. Okay, so now the idea of making a stack is to use it, to add data to it, to delete data from it, to do any sort of manipulation, whatever I have to do. Okay, and ultimately what am I doing? I'm storing my stuff in the stack, right? Now I'll see the operations that can be performed on a stack, right? Operations. So the first operation is what? Inserting data. Okay, and data insertion is also called what? Push. See these terms, push or pop, that just I would just be telling you all are very universal and conventional terms used, okay, whenever you're talking of stack in any programming language. If you're talking of inserting data in any of the programming languages in a stack, it's called push, right? Second is deleting data. Deleting data is called pop. Okay, then third thing is viewing topmost element. And which is the topmost element? The element which is added the last, okay, which is on the top. and that's called peek. You're just peeking into the stack to just view or display the topmost element. And finally is traversal. Traversal means what? Traversal means going through, okay, the entire stack element by element, displaying stack elements, right? So now we'll just go through how to perform these. Fine. How to take up these. First of all, you need to understand, right? Initially, when I take a stack, I take the stack and it is what? It is empty. Why? Because there's no element in my stack. Okay, it's just empty. And then what is that I need to do? I would first take up push operation or insertion operation. Okay, and how am I going to do it? I'll just define a function, and even before that what I do is I just take an element, or I'll just do one thing. I'll just make it in a function only. I'll just define a function for the same. So my first function is, say, I just write def push, okay, ele is my first function. Now what am I going to do in this? See, there's one more aspect of a list which I have missed out. The reason why am I choosing a list, right? Sorry, I just missed it out. See, list size is dynamic in Python. What does this mean? It means that there's no limitation to how many elements are you going to add to your stack, or how many elements can you add to your stack. I can just go on and on and on. So it's dynamic in nature. You'll never encounter overflow condition. Overflow condition is what? If in a particular data structure, say a data structure has size 10 and I somehow intend to enter 11th element in it, it's going to give me a overflow message. But in case of list in Python, its size is dynamic in nature. So there's never ever an upper limit or a cap on how many elements can you add to a stack. So this is also one good reason to use list, okay, to implement a stack. It was really, really important. And when I'm talking of overflow, I'll just talk of one more condition, and that is underflow. What is underflow condition? Underflow condition means my stack is empty. I have nothing to delete. I have nothing to traverse. That is called underflow condition. Okay. Now, this function is meant to enter an element to my stack. So what am I going to do here is that I say I enter an element. Say my element is an integer. I would write int input enter element. Okay. Now what am I going to do? Simply see, in a list, when I have to add an element, which function would I use? I would use append function, right? So simply what am I going to do here? I'm simply going to write s dot append ele. Why have I used append function? Because append function is used to add an element at the end of a list, and that's what I want. So using append function accomplishes my task of adding element, okay, in my list. Now say I've entered here, say I've entered 5, right? So now this is my stack, empty stack, okay? But as soon as this line gets, these two lines get executed, 5 is entered here, correct? And if I put this in a loop and I keep on entering, so say after 5 I enter 2, then I enter 3, then I enter say 10. So this is how it continues, okay? So initially the first element entered was 5, which is the bottommost now. And if I intend to delete now, which one's going to be deleted? 10 is going to be deleted. The lastmost element or the topmost element is going to be deleted. Fine. So in my next sheet now, next point is deleting element. How do I delete an element? Again, I define a function def, okay, pop element. Now, Which function do I use to delete element from the end of a list? As simple as just using a pop. And what does pop function do? Not only does it delete element from the end, it even returns it. So whichever element is at the end or at the top is transferred or assigned to X, and the element can be displayed or used in whichever manner do you want. Okay. Now, but before deleting or before popping out, do I not have to check the underflow condition? What am I going to delete if there's nothing there in the stack? Okay, so what do I do is, say my stack was S, okay, and I'll simply do what? I will write if, okay, S equals to empty. I can even write if len S equals to 0, whichever ways you want to write. Okay, if S equals to empty, print underflow. Getting it? I mean, what does it mean? It means that the stack is empty. Else, now if it is not empty, then what am I going to do? I'm going to write ele equals to S dot pop, and I would simply print ele, the deleted element. So effectively what? I'm using two functions. I'm using append, I'm using pop. Append to insert element at the end, and pop to delete element from the end. And we know what this is, what append and pop are being used for. So now this is how you delete. Okay, then I move on to traversal. Again, say my function is def display, okay, underscore stack. Now see, again I have to check if it's the underflow condition, because if it's empty, what am I going to display, right? So again, if here I would do what? I would write len if len s is equals to 0, then what? Print underflow condition. Okay, else. Now remember one thing, say this is my stack. Okay, say this is my stack. So which is the first element? This is the first element, this is the second, then say this is the third element, and henceforth, right? Always when you display a stack, you display it in reverse order. So first 3 is going to be displayed, then 2, then 10, then 1, then 5. And how do I do it? How am I going to do it? I'm simply going to do what? I can do this for I in range. I want to display in opposite direction. So what am I going to do? I'll simply do what? len s is my stack, -1, comma, -1, comma, -1. And I'll do what? I'll print si. Now what is going to be the first? Say my stack has, say, 1, 2, 3, 4, 5 elements, right? So what am I going to get here? I'm going to get here 4, right? Fourth index, and from fourth index, I'll just, because my stop is -1, so I'll go till 0, and my step is -1, so it's going to go in reverse direction. So first fourth index, that is number 3, is going to be displayed, then third index, then second index, then first index, and 0th index. So remember, whenever you're displaying a stack, you're always displaying it in reverse order. Got it? Now peak means just you want to have, or you want to display the topmost element. How am I going to do it? Simply def top, whatever name, okay, I want to give to my function, I write it top display. Yeah, and I'm going to simply do what? Say my stack is S, I would simply write print S -1. Why? -1 is index of last element, and my topmost element is my last element, correct? Right? So this is how it is displayed, as simple as that. Fine. Now this, see, Abhi, I've just shown you all the functions without any arguments and parameters, right? But when you get questions to, write in answers to write in your exam, normally you're given, okay, I mean, in your exam questions, it's given like define this function with these arguments. So most of the time you are given questions wherein you define push underscore stack, and you're asked to pass, stack as an argument and even element as an argument. See, if the question says that element is also to be passed, then you're not going to read the element here, or you're not going to enter the element here. Remember, very common mistake that I see, what you do is, again, you do this. But why will you do this when already element is being passed here? So you're not going to again read the element, because the stack and the element is already passed. Correct? So here you're simply, because what am I doing? I'm pushing, so I'm simply going to do what? I'll write s dot append, right, ELE. I don't have to read ELE, because ELE is already being passed. The stack is already being passed. What does it mean? It's already available. Just use it. So I've used it. Similarly, you might get a function wherein, again, say pop underscore stack, and they ask you to pass the stack. The stack is already here, and you would simply do what? ELE equals to s dot pop. You get it? So these are few operations that can be performed on the stack and which are in the scope of your syllabus. Okay. Then next, finally, I move on to applications, okay, of a stack. See, one thing you have understood now, stack, what is happening when you're working with a stack? Say, you have the string hello, right? And you're putting this hello here. So what happens? H comes here, E comes here, then L comes here, then L comes here, then O comes here. Okay, you have pushed hello into it. Now if you pop out from it, how are you going to get? You're first going to get O, then L, then E, then H. What is happening? Reversing. So the first application is reversal. Okay, reversal of words, yeah, strings. Okay. Then second is, mathematical evaluation. See, though it's not beyond your syllabus as of now, but earlier we used to get questions and problems on evaluating arithmetic and logical operation expressions using stack. You don't have it in your syllabus as of now, so doesn't matter. But stack is used for mathematical evaluations. Okay, internally, even in our computer system, if I have this 5 plus 4, it's not evaluated as 5 plus 4. It is evaluated in postfix notation or prefix notation. And when it's being actually, evaluated, okay, it's evaluated in either of these notations, and this goes into the stack, and the stack helps in evaluating it. We'll not get into the details because it's not part of your syllabus anymore. Okay, so now, next application of a stack. We all work on, text editors. Okay. It enables undo option. What happens when you're working, say, on a text file? Okay, you write something, you make changes, again you write something, you make changes. So what is happening? Every time you make a change, the state of your text editor before the change was made is pushed onto the stack. Correct? You make another change, again the change, before the change, the original, the unchanged one is pushed onto the stack. So what happens is when you undo, so now you have pushed that version of your word or your text editor, okay, which was without the change that you made. So when you pop it out, you get undo means popping out the one the version or the state of your content which was unchanged. So every time you do undo, what is happening, basically the content which was pushed before making a change is popped out. So that is how undo operation happens in text editors. Okay, then yeah, you all must have experienced whenever you access a web page or a website, okay, you go to a web page, right? After that you traverse to next web page, to next web page, again you have an option of going back. What is happening here? Again the stack comes into action. What happens is, you're on a web page, you move on to the next web page. Before you move on to the next web page, now this web page is pushed onto the stack. Then you move on to the third web page. The second one is pushed onto the stack. You move on to the fourth, third one is pushed onto the stack. So what is happening now? If I go back, as so say I'm on web page 5, okay, as soon as I click on back, what is happening? Because my web page 4 is on my stack, the last one that I pushed onto the stack, I click on back, it's being popped out from the stack and I get web page 4. If I want to go to web page 3 further, when I click on back, web page 3 is popped out. The URL, obviously the URL of web page 3 is popped out. So that's how stack comes into action when you, yeah, okay. Finally, you know what? Function calls. We whenever in our program we define functions, we call a function. At that time also a stack comes into action, okay. The previous execution control, wherever your execution control is of the next statement, that goes, the address goes into the stack, so that after your this thing execution of the function, your execution control moves on to the next statement which is to be executed. Likewise, the arguments or the return, everything's been stored in the stack, and as and when required is popped out of the stack. Then yeah, so these are few applications of stack. So after this I would come upon questions that you get in your board exams, right? So we'll just take up questions. Now if I just take up this one, see, a list containing records of products as, this is what, it's a nested list, right? Okay, write the following user defined functions to perform operation on stack. So my stack name is product, okay, and L is, okay, my data, my information which is to be stacked, which is to be pushed onto my stack. So what is it? Okay, so now you see here it's without arguments. So to push an item containing the product names and price of products costing more than 50 into stack. Now what I need to do is I need to only push those product names and price where price is greater than 50. So now you see, if you just check this list, okay, so this one is what? 0th index of first element, this is first index. Okay, so price is at first index, 0, 1, 0, 1. Very simply, how am I going? And see, remember in these questions, one more thing, whatever is the name of the function, it is to be as such used in your answer. So what am I going to do here? I'm going to write def, okay, push underscore element, right? And what am I going to do here? Okay, I already have this list. So simply I'll do what? I'll write for I in L. Okay. See, if it is not being passed here, you can even pass it here, or you can define it here. Just copy it here as it is, right? Or you pass it here. For I in L, right? I, rec, whatever name you want to give it. What is that I need to check? If I 1. So at the first iteration, I has what? It has the first element of L, which is laptop, 90,000. So if I1 means if this one, Okay, I1 is this, is greater than 50. Then what am I going to do? I'm going to write to what? My stack name is product. I'll write product dot append what? My first record is in I. Is it clear? This is what has been asked in the question. I've done it, right? Now I'll take up the second part of this, and which says pop. So I'll do what? Def pop element. Here again, if you wish, you can even write L comma product. Okay, because I'm using it here. Now pop element. I take my stack name here, product, right? And here it says that if display stack empty, if the stack is empty. So what am I going to do? I'm simply going to write if len product is equals to 0. What am I going to print? Print stack empty. Okay. And else what am I going to do? Simply else I will do x equals to product dot pop. And if it says to display, you just print x. Correct? So what is it going to? Whichever was the first element that's pushed in, that's going to be popped out and displayed here. Right? Now I take up the next question. Yeah. Here I've taken again. Now see, in this question, it's been passed. So accordingly, I'm going to do. So what does this question say? That this is the list. Fine. A stack name book stack stores book records. Okay, each record in a list containing 3 elements. So again, it's a nested list with each list within the list containing book title, author, price. There might be n records in it. Okay. Now this is an example of a record. Write the following user-defined Python functions to perform stack operations on book stack. Push this function receives the stack book stack and a new record, new book argument, and pushes the new record onto stack. It's again very simple. Now remember, again, one common mistake I see. What you do is, okay, I'll write this here, def push underscore book, and what is being passed as argument? Book stack. It's the stack name and new book record. Now see, the new book record is being passed here. You don't have to create it here. This is one common mistake I see you all doing again and again. You're not going to do it. It's already been passed. You just need to do what? You need to push it in book stack. So what am I going to do? I am simply going to write book stack dot append what? New book. New book is a record which is already being passed here, right? And in the next question, pop book, this function pops and returns, so it's same. Here it should display underflow. The entire message which has been asked in the question has to be displayed if the stack is empty, and you know how to do it, right? Okay. Yeah. I want to do this question because see, abhi I did the questions which were list based, and now I take up a question that's what? It's a dictionary based question. Okay. So what does this question say? A company having various departments and number of computers are stored as key value pairs. This one set up in a dictionary as given below. Now you need to do what? Write user defined functions to perform the following operations. Push the keys. Keys as in you need to push HR or quality or support, production, supply, depending on where the corresponding value is 25 or more. I mean equals to 25 or more. And then later on you just need to pop, and if the stack is empty. Yeah. So now see, here we are working with this thing, dictionary. So push the keys, and yeah. So I'll do what? I'll just do this, def push underscore whatever data, whatever name you want to give, because here no name is given here. And what I do is, okay, is the stack name given? Stack name is department. I take it here, and my dictionary is set up, right? I take it here. Now what am I going to do? I'll traverse the dictionary for I in setup. What do I get in I? I get key. And if what is the condition? Greater than n equals to 25. So I'll write if setup I. What setup I means? Setup is a dictionary, I is the key, so this as a whole is a value. If setup I is greater than equals to 25, what is it I need to push? Okay, let's check into push the keys only. Okay, so we just need to push key. So what am I going to do? I do department dot append what I. This is the key. I've pushed it. And again, pop is very simple, def pop, and pass department. You don't have to pass, which is your stack, what is your stack name? Yeah, department, just pass department and check for underflow and just pop out from dep. Okay, this is how. So, and there are many other questions. You can just go through and practice as many as questions you all can. So I think this should help you all in understanding how a stack is worked upon in Python, and the session would help you all in understanding the questions that you get in your board exams, right? I think it's all and enough that you need to understand and you need to revise for your board exam. So very soon I'll catch up you all with next session of mine, which would be on file handling. I'll be starting with text file, following with binary, and then CS.